Check, check. Okay. Okay, we're back. We had a minor YouTube streaming issue where YouTube cut us off because we were streaming audio from the room, which we didn't have the rights to stream, so we had to restart some streams. But we're back in action. We're back live. Okay, welcome back. Let's get started again. I'll pass it off to Marek, who's our next speaker.
Okay, let me test this. Can you hear me like this?
Yes.
I guess so. Can you hear me like this? Better? Cool. Okay, I'll do it like this. My name is Marek Vašur, and I'm going to talk about safe update of firmware blobs in bootloader stack today. I'll split this talk into 4 sections. First section, I'll talk about what the bootloader stack actually is. What is it that I mean by that? Then I'll move on to porting U-boot SPL. Then I'll talk about starting up TOS from U-boot. And finally, I'll talk about Falcon boot mode, which is potentially interesting for deployments where security is important. First of all, bootloader stack. So bootloader stack is everything, all the software that runs from the point where you power on your system all the way until the operating system kernel takes over. This is the whole software stack that's in there. The bootloader stack used to be very simple. It used to be a single program in general, which was running from some sort of a memory mapped parallel NOR flash. Back in the days, the software could have been U-boot, something like this. It initializes the hardware, it initializes the DRAM, loads the kernel, starts the kernel from the DRAM, and hands over to the Linux kernel or any other OS kernel. That's how it used to be, but nowadays the bootloader stack grew much more complex. It turned from a single program into multi-component, multi-project affair. Nowadays, the first stage of the bootloader is no longer in some parallel NOR flash, it's in the SoC itself. It's often closed source. It's called the boot ROM. That one loads some sort of a first stage bootloader, which could be TF-ABL2, it could be U-boot SPL. That loads another bootloader stage, which could be U-boot, could be OptiOS. That could then load U-boot, and then that starts the Linux kernel. So it's a multi-project thing, it's complicated, but it's all baked together into a single binary, which you call bootloader, and it's part of your bootloader stack. Yes, it is complicated, but it's not as complicated as it's becoming. There is more that is coming. So far, the bootloader stack was running on a single core. The future that is now belongs to safety cores. Basically, some sort of a Cortex-M or Cortex-R starts potentially closed source, maybe open source, maybe free software bootloader program, which could be completely custom written by the vendor that sets up the whole platform. And then when the whole platform is set up, including DRAM, it loads U-boot potentially into DRAM and wakes up the application cores, which are the cores which run Linux, and U-boot literally wakes up when the platform is fully initialized by the safety cores. Communication with the safety cores, that happens via some mailbox interface. So whatever is running on the application cores is completely isolated from the hardware. There is no longer any hardware interaction. But in this talk, I'll go one step back. I'll return to the present, where this whole bootloader stack, which is multi-component thing, runs on a single CPU core. So all these stages in the bootloader stack run on that one core. And I'll talk about this because there are still problems in there, which are then moving to the future part of it as well. Now, since there are multiple bootloader stages, some of these stages may need to protect themselves from some sort of an interference from the follow-up stages. This is done on the CPU side as well as on the bus side. On the CPU side, the protection of the more privileged software, which is running at the very beginning of the bootloader stack, is done using exception levels, which are specific to the CPU core. On ARMv8 CPU cores, ARMv8A and newer, there are 4 exception levels, EL3 all the way to EL0. EL3 is the highest privilege level. This is where the firmware runs, the secure monitor runs. And this is basically unrestricted access to everything on the hardware. It can write any registers, it can set up any sort of protection. EL2 is then the hypervisor. That's also where U-boot is running, bare metal Linux is running. EL1 is virtualized OS, virtualized Linux potentially. And EL0 is unprivileged user application. The idea here is that the highest privilege level firmware can set up some sort of a secure MMU tables or this kind of protection, and then start the next stage, say, for example, U-boot in less privileged mode, and U-boot cannot access this protected memory. This can be useful if the protected memory contains, for example, code of the more privileged bootloader, or it contains some sort of secrets which the less privileged software is not supposed to access. It is possible to switch between these exception levels from the more privileged one to the less privileged one. This is easy. The software simply decides that it wants to drop exception level, and it drops from EL3 to, for example, EL2. But it is also possible the other way around. But for that, the less privileged software has to trigger an exception. When the less privileged software triggers an exception using either of the instructions, SMC or HVC, the exception is taken in the destination exception level, which for SMC is EL3, for HVC it's EL2, and some sort of a handler for that exception starts running with this higher privilege level. For the SMC, it's usually the secure monitor that installs an exception handler in EL3 for the SMC exception and handles it. Now, what can this be used for is for the less privileged software to somehow trigger the more privileged software to perform some action. Specifically, the less privileged software can request services from the more privileged software, and it's not only an exception that it can trigger, but it can also pass in some registers. ARM has a specification which is called SMCCC, SMC Call Convention, which defines which registers are supposed to be passed alongside the SMC exception or HVC exception for the secure monitor to interpret it correctly. It says basically that R0 is some sort of a function ID, R126 are parameters for the function, and there are additional specifications, PSCI and SCMI, which define some of the function IDs and what they are doing. In case of PSCI, these function IDs can bring up CPU cores, start them, stop them, reset the system, this kind of stuff. In case of SCMI, this is used to control regulators, enable, disable clock, these kinds of things, PINMUX. Now, the problem is that the SMC handler in EL3 is installed very early by the most privileged software on the platform, which is part of the bootloader stack. And both U-boot and Linux kernel may depend on these SMC calls, and especially that the ABI will be stable for these SMC calls. Sadly, with vendor BSPs, this does not always happen, and this leads to a disaster. Problem is, what can happen? The better case is that if you have a system with a stable bootloader somewhere in production, you deploy an update which has a new Linux kernel built potentially against new vendor downstream BSP, then the vendor decides, okay, we will change something here with the SMC interface to better cater for our customer requirements, which is nice because they care for their customers, but in the meantime, they maybe change the ABI a little bit and your system fails to boot, which is not good for you in production because then you have a problem. So you have to recover the system. Hopefully, you already have AB updates, so the system will fall back to the old version of the Linux kernel, which will be compatible with the old bootloader. Good. But there is the alternative. If you also update the bootloader to kind of solve this ABI problem between bootloader and your Linux kernel, and the new kernel doesn't boot, then also your old kernel is unlikely to boot because it depends on the old bootloader ABI, which is no longer there. And your system is basically a brick, not recoverable one. This did happen before. It actually happened between STM32MP13 with their old downstream bootloader and mainline kernel. The SCMI ABI has been different, so the mainline kernel just did not boot on it. And this made me wonder, okay, what can we do about this situation? How can we prevent this ABI problem? One thing obviously would be to teach the vendors that if they once define some sort of an ABI, they should stick to it and never change it. But it seems we cannot really depend on this, so I took an alternative approach. And I realized, okay, instead of doing this, let's bundle together the Linux kernel and whatever blobs provide this ABI, and it will look something like this. So currently the bootloader stack looks like this. The boot ROM is at the very beginning, then there is TFA, which does hardware initialization, that's essentially BL2. Then potentially there is trusted execution environment, which provides the PSCI or SCMI services on ARMv7. Then there is U-boot, and then there is Linux. They both depend on the services from the T. The change I did was replace the TFA with U-boot SPL. That's because of security considerations. I then started U-boot directly, and from there on, I was able to start the trusted execution environment and Linux kernel in a single fit image together. This way, I have no dependencies on any potentially changing ABI before this point. This doesn't depend on any ABI, and these two things have an ABI between one another. The second thing I had to do was teach U-boot to start OptiOS properly on ARMv7A. This gives me the ability to do AB updates because once I can reach U-boot, U-boot has a built-in ability to do fallback boot. It's fully scriptable, so I can select whichever image I want to boot. And then at the end, I enable the Falcon boot mode. I'll show you how to do this as well. Replacement of the TFA BL2 with U-boot SPL. This is actually quite easy because if you have already U-boot running on your platform, and it only depends on some sort of a PSCI SCMI calls, then you already have also the templates of all the drivers which you will be using, and you will be able to use them in the SPL as well. So the first step when doing this kind of thing is you have to look into the drivers, see if some of them depend on any PSCI SCMI calls, and if so, then replace those with direct register writes. And this is mechanical because this is something you look up in the datasheet and then just fill in the register writes into the clock PinMux regulator driver. Easy, so far. The other thing which you will not have, however, is a DRAM controller driver. So this is something you will have to write for the U-boot SPL to initialize your DRAM. On the other hand, this is also not complicated because there are very few DRAM controller vendors on the market. There is Synopsys, there is Designware, there is Renesas, probably a few more. So it is very likely that if you look into the U-boot code base, you will find similar driver for the controller which you have in your SoC already. You will be able to either extend it or fork it, and then you will have DRAM running. The rest of the SPL porting is integration changes. I did this on the STM32MP13 SoC, and I was lucky that PinMux driver was already written It didn't depend on any PSCI SCMI, so I could reuse it. Clock driver did need changes, but this was only a matter of filling in the register poking. Drum controller driver could be derived from previous generation SOC, the MP15, with only slight extensions, and then I had to fill in support for new boot image type into MK image. Patches are posted. You can see the result. So if you want to look at how this SPL porting actually happens, that's all of it. That's all the work. And as you can see, the actual implementation is smaller than all the fixes which I prepared up front. So while you are doing this kind of thing, you will probably find also a bunch of things to fix in the code. I have a few hints when doing this sort of an SPL porting, which you should keep in mind. One of them, SPL is size-constrained environment. It's running in SRAM, so you have to be mindful of this. You will not have infinite stack, you will not have infinite heap, and you will have no protection. That means if you allocate too much memory, you will run out of heap. If you overflow your stack, it will just overflow somewhere and potentially write into a register area. That can happen. There is no protection, not at all. The other thing is look at debug UART configuration option in U-boot. This will give you very early on UART output as soon as possible. It's much easier if you can use printf very early to print your stuff than it is to blink some sort of an LED or try to get information out of the SOC in any other way. Lastly, you will be matching behavior of the system to the datasheet, and you will be going back and forth, and you will have to try multiple times some sort of an operation until you figure out how it actually works and what was meant by that one sentence in the datasheet. Find a way to do this quickly. Find some easy way to compile your SPL and start it on the SOC and see what's happening. For the MP13, that's DFU util for USB upload or JTAG OpenOCD. Here is an example how to use the DFU util on the MP13 if you want to start SPL quickly, how to start OpenOCD. Slides will be available so you can just then look at it afterward. OpenOCD has the benefit that it's scriptable in TCL. So you can write quick abbreviations, start SPL, stop the target, load the SPL code into the SRAM, start the SPL. Same thing for U-boot. This will help you greatly, and it will expedite your development very much. Here's an example of how OpenOCD looks like, starting off the SPL. This is the output you will get from OpenOCD. Okay, now, what about U-boot? So when you are finished with porting SPL and removing all the SCMI, SMSQL dependencies, U-boot and U-boot SPL actually shared drivers. So when you did this work for the SPL, you also did this work for U-boot. That means at this point, you should also be able to start U-boot just like that. So I will move to the next section, which is start OptiOS from U-boot. Before I get into it, Opti and OptiOS are two different things. Opti is a bigger project which provides the whole trusted execution environment and all the stuff around it. OptiOS is only one component from the Opti project, which provides the runtime for trustlets and which provides the services to the non-secure world. There are also trusted applications which are not part of the trusted execution environment. These run in the secure world on top of the T. They are provided by developers of these trusted applications. There is OptiOS client, which is provided by the Opti project. It provides the supplicant client to communicate with these trusted applications. There is a test suite and so on. But in the rest of this talk, I'll talk only about the OptiOS, which is the library/runtime which provides the services, because that's the interesting part. The OptiOS library/runtime is installed very early on. either by TFA BL2 or it can be installed by U-Boot SPL. It has to run very early on because it has to install on ARMv7 its own secure monitor handlers. On ARMv8, there is a slight difference that the secure monitor is external to the OptiOS, so the handlers are installed potentially by TFA, and OptiOS is only loaded into memory, and it doesn't install anything on its own. Right. To invoke the OptiOS, this is called or triggered by some sort of an event which is coming from the non-secure side. Often that means Linux kernel wants something from the OptiOS, it does SMC, the OptiOS handles it somehow. It doesn't have any sort of internal scheduler, so it doesn't really behave like a separate operating system would be running on your core. It's event triggered. On ARMv7A, the OptiOS has its own secure monitor, and starting the OptiOS is actually very, very simple on v7a because it does all the work for you that needs to be done to install the secure monitor. You really don't have to do much there. To start OptiOS on ARMv7a, it's basically a matter of picking up the right file because when you build OptiOS, it will generate multiple binary files. There are some which have some sort of a header in front of it, some are ELF, executable, loadable format, these kinds of things. I picked the traw.bin because this is literally built of OptiOS, which is linked to a specific address without any headers, without any other stuff. This file has to be loaded to the link address because it's linked to that specific address. And then it is actually enough to jump to it and it will do something, but it expects 5 registers to be set up correctly to actually do something meaningful. There are 2 registers which have to be 0, CPU registers R0 and R3. R1 and R2 are passed through to the software that runs after OptiOS, and link register has to be set as well. Because the link register points to the next stage to which OptiOS actually returns. So when OptiOS does its initialization, when you jump to it, the initialization will look something like this. It does its own internal state initialization, initializes its drivers. When it's done doing all this initialization, it triggers the secure monitor on ARMv7a. The secure monitor actually signals to the OptiOS that the initialization completed, and then it will pop stack and attempt to return to whatever was in the link register. And whatever is the OptiOS returning to, this will be running in non-secure mode. Usually that's going to be Linux kernel entry point. Here is an example of starting the OptiOS from OpenOCD. That's here on top. It's yet another thing. Load the traw bin to an address, jump there, do some stuff. At the bottom, same thing, done using U-Boot. I couldn't write to the address de blah 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 directly because that was protected by Trust Zone at that point, so I had to copy the data in there. But otherwise, you can see how the OptiOS is starting here. This is with debug level 4, so you get some debug prints there. And then it hangs because the registers were not set up, so it cannot really continue anywhere meaningful. Now, instead of hacking this somehow in U-Boot to set up these registers, I would like to use something else. And I would like to introduce you to FitImage first. So FitImage is a multi-component image type based on device tree. What this means is that it can serialize multiple files into a single file. Each file has some sort of additional description attached to it, and this all gets bundled into one single container file. The source description for the FitImage looks like this. It's based on device tree, so the device tree syntax should be familiar to you. There is an images node. Each subnode in the images node describes one image which is bundled into the device tree. There is reference to the data which are going to be bundled into it, type of the image, where it's supposed to be loaded, the entry point, and so on, checksum, configurable. Another image, which is a device tree. That's one part of the fit image. So it can just serialize like multiple images into a single file with metadata. But there is another thing, which is configurations. That's another half of the fit image. The configurations put all these images in the fit image together in some sort of a meaningful, well, configuration. It allows the user to select which of the images in the fit image fit together, and it allows the user to boot this specific configuration. When this happens, like for example here, there is a Linux kernel 1 that's a reference to the kernel image, and FDT1 that's a reference to the device tree. When user would boot this one configuration, which is actually default, U-boot would pick out the Linux kernel 1, place it at the right location, pick out the device tree, place it at the right location, and boot this combination of images together in the right order. That's what fit image is about. And when this fit image is assembled, it just produces a single file which U-boot can boot. OpenEmbedded can generate fit images since 10 years. U-boot can handle them. The integration is already in place, so that's that. Luckily for me, the OptiOS support, the image type for OptiOS is already in the fit image, so U-boot also knows that there is something like an image type T here. And I could simply bundle the T raw into the fit image, reference it in loadables, and simply let you would boot this kind of a fit image, which would then contain the Linux kernel, the device tree, and the OptiOS in this one single bundle, and generate the fit image like this, and it doesn't work. So I was debugging this, and I found out that the OptiOS implementation, the OptiOS boot implementation in U-boot was meant for ARMv8, and so I had to patch the boot code a little bit to detect that on ARMv7, if the OptiOS is loaded to a certain location, then I need to make a note that this happened, and when booting the Linux kernel, I had to add a little bit of a glue code that instead of directly jumping to the Linux kernel, would set up these 4 registers needed for OptiOS, the link register, and jump through the OptiOS to the Linux kernel. Yeah, patches are posted. The jump handler is completely banal. It's just a little piece of assembler code. The changes to the kernel boot code look like this. One potentially interesting thing is this fit loadable handler macro, which allows you to define for specific fit image types shreds of code which will somehow get executed when such a loadable appears in the fit image. So I used it to make a note that the Opti was loaded, and then when the system was just about to jump to the Linux kernel, I invoked this assembler code, jump to the Opti. The Opti runs, yeah, it looks like this. Fit image gets loaded, U-boot prints all kinds of information about the fit image, kernel, device tree. OptiOS actually got loaded to the E location, and then U-boot is just about starting the kernel, and OptiOS printout shows up in the output, and Linux kernel starts booting, and Linux kernel can communicate with the Opti that just got started. Yeah, patches are posted. One word of advice when it comes to the OptiOS, keep in mind the OptiOS is security sensitive code. It is important to configure your trust zone correctly, otherwise OptiOS may have issues or it may be unsecure. The trust zone configuration is done, this is platform specific. It's mostly a matter of configuration of bus firewalls, and this is something you will have to figure out based on your SOC datasheet. On the MP13, it was a matter of configuring the ETZPC and TZC, but this is going to be called something else on your platform. On IMX, it's called AIPSTZ, for example. I'm sure you can find it in the datasheet. It will be somehow branded Trust Zone. So there is that. Okay. Let's talk about AB update. So the current state, the current situation we actually have right now is that we have U-boot SPL, we have U-boot, capable of booting Linux kernel, device tree, and FitImage together from one single file, which is stored somewhere in the file system. Now, U-boot also has the ability to do fallback boot. That means if some sort of a boot counter overflows, it will run some sort of a different boot script. And this is already part of U-boot for 20 years. It's been there since forever. And with these tools, that means OptiOS Linux kernel and device tree being in single file, and the ability to start one or the other FitImage from some sort of a storage, it's possible to implement AB update whichever way you actually need it to. And the thing is, if the FitImage fails to boot and Watchdog triggers and U-boot detects this, it can simply boot another FitImage just like that, which could be the recovery FitImage, which will have its own copy of OptiOS, which will have its own copy of device tree and Linux kernel. It will boot all these things together, actually, and there is no danger that the B copy or the recovery system will have any sort of ABI incompatibility because you are booting essentially the old OptiOS copy at that point. There is no shared OptiOS copy which would be providing any one ABI. And that's how it is. That's how it can work, I believe. Now, so far, I was talking about keeping U-boot in this boot pipeline or in the bootloader stack, but there is one more problem with this. The problem is U-boot has scripting capabilities. U-boot has network stack. U-boot has USB stack. It has a lot of stuff in this, and that makes it massive attack vector. With this setup, which I demonstrated before, U-boot would be running with the highest privilege level on the platform, and that's potentially not going to sit well with security-minded people. It's not a good idea, basically. But U-boot had for a very long time support for booting these FitImages directly from the SPL stage. And the SPL stage on the MP1.3, even with the OptiOS booting support and all that, is like 100 kilobytes, so it's much smaller than the U-boot, which is much bigger. And I would like to show you how to actually enable what's called the Falcon boot mode, which is the name of booting these FitImages directly from the SPL stage. In the next slide. One more thing about the Falcon boot mode. Yes, it can boot FitImages. The FitImages can contain Linux kernel, device trees. It can also contain TFA-BL31. So if your PSCI provider is TFA-BL31, you can boot it as part of the FitImage from the SPL stage. It can boot the OptiOS from the FitImage from the SPL stage. And yes, it is capable of AB switching as well and fallback to actually start U-boot FitImage. So the Falcon boot mode is also capable of selecting between booting Linux kernel directly or booting some sort of a fallback U-boot FitImage for factory manufacturing, this kind of stuff. To enable the Falcon boot mode, define this configuration option, SPL OS boot, make sure FitImage support is compiled into the SPL, and besides that, you have to define configuration options which are specific to the boot media which you are going to use. The SPL is a very small piece of code. It's not so flexible as U-boot. That's why a lot of things are hard-coded into the SPL. In this case, where the U-boot is, on which sector, on SDMMC in my case, and where the kernel is in the SDMMC in my case. Right, I have 2 slides. left. The SPL start uboot function, this is the selector between boot uboot from this address or boot the kernel from this offset. Now, I had to modify the function which starts the Linux kernel in SPL as well to handle the opti extras. I could reuse most of the work I did in the uboot, and the patches are again posted, so if you want to look at it, the slides actually have links to all these patches, so you can look them up. Finally, A/B switching. This has to be hard-coded into the SPL, override this board-specific function in your board port, and select which of the A or B copy of the Linux kernel you would like to boot from whatever offset in the MMC. So it's, again, a matter of implementing one function in the SPL. So to wrap it up, TFA-BL2 can be replaced by SPL. This gives you automatically the Falcon boot support, and also it's not so difficult. OptiOS can be started from uboot. It makes it easier for you to experiment with OptiOS. If you are doing OptiOS development, you can start it from uboot, maybe via TFTP, makes it easier, and also avoids any dangers of ABI incompatibility between the Linux kernel and the OptiOS bootloader blob. And if you are then deploying this stuff in production, then I would recommend you look at the Falcon mode, boot the FID images with OptiOS directly from SPL, which removes uboot as the attack surface entirely from the bootloader stack and improves platform security. Thank you for your attention, and if we have time for questions, then yeah.
We could take one question, I think, before we move on. If there's any questions? Otherwise, we can badger Marek at the restaurant
Otherwise,
tonight.
you can just reach me here. I'll be here all 2 days. So. There we go.
Okay. So I know it's not a good idea, but what about if you don't need OptE?
Say again?
Here. What about if you don't need OptE and you directly Falcon boot to Linux? How much time would that cut from boot time? Is it possible nowadays to?
It is possible to directly boot Linux without the OptiOS, yes. This is what
Would
the
it
Falcon
work?
boot was meant to do, actually, at the very beginning.
Yeah, but do we know it works now with ARMv8?
On ARMv8, you will most likely have to start at least TFA-BL, well, either SPL or TFA-BL2 and BL31 for the PSCI provider, because on ARMv8, you definitely do need PSCI. The Linux mandatorily depend on that, on V8. You would actually thus implement PSCI provider as well, so you could potentially try to use this. On Renesas, there is a fallback PSCI provider in uboot, so in case there is no other PSCI provider, uboot will provide basic PSCI provider for the platform so the Linux kernel can boot.
Can you include
That's
that
an option.
in the kernel instead?
Say again?
Can you include that in the kernel as a?
The PSCI,
Yeah.
I think there will be some opposition to this.
I know.
On ARMv7, this is how it worked. On ARMv8,
No, it's not going to happen.
send patches and see what happens, I would say. I'm not the guy who is going to decide the fate of this patch set.
Okay, thanks, Mark.
Sure.
Okay, for our final talk of the day, we're going to have an AI talk. It's 2025, so we have to have a little bit of talk about AI. It's not the whole conference, but this is the talk that's going to give us a lot of stuff to argue about at the restaurant tonight. So this is where we're at. So welcome, Christoph.
Thank you very much. Comment est-ce que j'enlève ça? Comment est-ce que j'enlève ça? Kevin? En plein écran? Ben, là, j'ai 2 écrans, tu vois. Ok. All right. So this presentation was done with AI, so if it's going wrong, it's not my fault. Let's start. So my name is Christophe Conil. I'm a software engineer with 20 years of experience in embedded and low-level stuff. I work together with Belieber on multiple projects. And I have full stack knowledge also, which means I do some back-end development and some front-end development as well. I'm the founder of an association company which is called Save My Planet. Save My Planet's goal is to develop some devices, which goal is to halve the electricity consumptions in households using different new products that didn't exist until now. So it's only research-driven smart home products and solutions that pay for themselves really, really fastly. The goal is to create open source hardware for this, so releasing the schematics, releasing the hardware, and open source firmware code as well. At least that's the big goal behind that. Let me present a few of the projects that we have. I'll go quickly about that. So we have one of the first projects we have is the Sunflower. So it's basically a device that you would put in your garden that has a big mirror, it's called an Heliostat. And it has 2 dual-axis stepper motors and sends back basically the sun from your garden into your house. It can follow the sun, it can follow the moon, it can follow multiple different astronomical objects. We have developed our own PCB for that. That's the latest, that's the most recent project, so it's not fully finished, but it's ongoing. And interesting also, since this device will be located sometimes far away from the home, we have a MQTT to LoRa software bridge inside it. That's the first project. Then we have a second project which is called the Breathing House, some kind of intelligent ventilation system. So you would have to imagine you would have a ventilation on the north side of your house and one on the south side of your house. And you'll basically get heat when wanted and get cold when wanted also. We have, for each and every model, 3 different PCBs communicating over I2C. We have lots of different sensors, BME680, SCD41 for the CO2. We have to manage 2 different fans over PWM. And each and every module in your house communicates with other modules over MQTT. Last but not least, we have the EcoThermostat, which is a thermostat. Basically, everybody has a water heater at home. And the idea is to replace the thermostat of your water heater, and from day one, you would almost halve the energy consumption of your water heater. For this, you have ACS 724 current monitoring sensor. You have off-grid communication, which is so that the device is still able to communicate even if you don't, if it's removed from power. You have a high wattage support, since we are supposed to handle almost 4,000 watts. So those are 3 different projects I'm going to talk about, and I'm using a lot of AI to be able to develop this project. We have a very, very small team, and it's a part-time job, so we heavily rely on AI to be able to develop all this stuff. We have a common platform, which is a ESP32 with 4 MB of flash. We have custom PCBs, as said. We are running on FreeRTOS, and we have a strong hardware abstraction layer. Almost, I mean, the project share about 90% of the code, so this is really nice. We have OTA, we have low power sleep modes, we have lots of different functions which could be implemented despite having not so much time, thanks to AI. On the front-end side, we have an Android, iOS, Dart Flutter app. I don't know if you ever coded with that, but that's interesting. I never coded in it, but I still did an app, so that was nice. And we have Firebase based backup, and everything is communicating over MQTT and TLS. All right. So generally, when we develop in embedded, we have a few stuff that we do really well. We do drivers really well, but there are some stuff that we don't do really well, or which are really, really time intensive. So integrating external libraries, I mean, getting into those libraries, understanding how they work, sometimes debugging them, can take a lot of amount of time, and it's not necessarily has not necessarily the biggest advantage. We have cross-layer dependencies. On my case, we have firmware and we have the application, and we have lots of dependencies between both. And as long as the projects are small, it's easy. But if the project gets bigger, we have hundreds of signals, hundreds of variables, and it can get messy to be able to track them. Test coverage, everybody loves to do tests and write a lot of tests, so we are doing that a lot. And debugging can also take a lot of time. So based on my own experience, code comprehension used to be hours, now with AI can be minutes. New code. Documentation, instead of taking days, can take minutes. Test development, instead of taking days, can take hours, and tool creation instead of taking weeks, can also take hours. So I'm going to present a few recorded sessions that I did that will showcase one entry for each and every of them. And we also have bug identification. Generally, when you write a bug, you don't know about it, so finding it can take a huge amount of time. Using AI, you might be able to catch a few bugs even before deploying, which is pretty cool. Under time pressure, essential aspects are often sacrificed, yeah, sure, leading to problems afterwards. So I developed a tool. Let me check if I can show it here. Apparently, yes. So I have a tool that's doing an analysis between my backend code, my firmware code, and my front-end code in Dart Flutter. And when I run it, I see each and every symbols which are used in the app, and for example, not in the ESP, or the opposite. And as you can see, there are lots of them, so it's hard to keep track. So this is the tool I'm using a lot. And I don't have any documentation for it. So if I want to give out this code to somebody else, he will need to understand what's going on with this. So I'm asking Claude to write documentation for this tool. So starting Claude in command line, asking, I have a tool called create analysis or start analysis or something like that. So this is run directly in a code directory which has about 50,000 files inside. So it's really open. And I'm asking him to write a quick documentation about the functions of this tool that I just ran in HTML, integrating a mermaid to explain how it's working. Yeah. Starting the tool. I didn't give him the real name of the tool, but it'll start exploring, searching for Python, starting for Bash script. He found one which name is more or less the one I asked for. This tool calls multiple other tools, as you can see. He then reads each and every of these subtools and will create a documentation based on that. So we'll wait. This has been sped up by 100%, so it's 2 times faster. And you can see just created the HTML documentation. So this took merely 1 minute, and this is the documentation output. So The symbol analysis tool is a comprehensive system for analyzing and comparing symbol usage across the Flutter app and the ESP32 firmware components of the Fleur de Soleil project. How to use this tool, it explains, okay, it search for configuration keys, it search for sensor data, it search for MQTT topics in both projects, how to start, output formats. Then we have an internal architecture of the tool. Analyze symbol calls for different bash scripts, which are also calling Python script, which are scanning for C++ file, how it's working internally, the outputs of these different tools, that comparing then the different outputs from each and every tool and generating the terminal output report. And then you have a comprehensive overview of each and every file which are used for this tool, with explanation for each and every case, and what actually the tool does internally, how it's able to find out those differences between the two tools. So this would have taken me easily a day to write, maybe two, right? And I could write it within a minute. So writing documentation is extremely, extremely adapted to AI code generation. Then talk to you before about this Airflow project that we are having, where you have one module on one side of the room, one module on the other side of the room, and each and every module has lots of sensors like humidity, like CO2, like air quality, like temperature. And writing test case is a nightmare because there are lots of use cases where one of the lots of use cases to cover to know when one module has to flow some air inside and when some other has to flow air to the outside. So I wrote one test using Unity, and this test for each and every device, you can see we have 3 modules. Each and every device has a temperature, has a humidity, and stuff like that. And I have only one test which is running using Platform.io and VS Code here because I didn't want to run into the VI, VS Emacs. And I thought VS Code would make everybody happy. So now starting Claude and asking Code to have a look at my code, the real code from the ventilation system, which manages all the different devices, and look at my test code also. Right now, I have just one test which passes, which is okay, I guess. It's better than 0. And I'm asking him to write a few other meaningful test cases. And I'm asking to think hard. Think hard will allocate some tokens for the AI to think, really reflect on what it's finding, and based on that, to propose something meaningful. This is still run in the directory which has 50,000 files, right? So it's really an open question. He created, I don't know if you saw that, he created a to-do list of items to do. And based on the review of the code, he suggested then like about, I don't know, 20 test cases where that would be meaningful. And those are meaningful. And then I just have to ask, yes, please implement those tests. And so he's creating his to-do list of writing the different tests. So basic temperature control mode, air quality control, critical condition, edge test cases. So like doing a lot, right? It would take a huge amount of time for a human to be able to do that. It won't be perfect. It's not perfect. But it's really a good basis, I think, in my opinion, to be able to continue working on. Because based on, you will have like 20 tests. Maybe they won't all work, but if you develop them all by yourself, you would take a staggering amount of time to do that. Right now, he wrote, I think, 510 lines of code, which are compiling. which is good also, and which completely relate to my code. So it's not something you would find on the internet, not at all. So, okay, we can see all right now I'm doing something a little bit called vibe coding. I'm not going through each and every test he wrote, but I'll just, trust it, and I'll run the code, and we'll see what happens. Maybe. Or maybe not. Oh yeah, here he told me he wrote 23 different test cases, 6 for the heating mode, 4 for the cooling mode, 3, whatever. And then I'm starting the platform I/O with all the different tests. As you can see, 12 test cases have failed, and 12 test cases did succeed. So it means I would need to analyze what failed and why, and correct the test case, or I can iterate with Claude also and tell him, okay, those test cases which failed, please have a look why they failed. Is my code failing, or is the test case failing? And in this case, he will, incrementally improve either the tests or my code, depending on the case. Don't trust it too much in regards to test, because after the third iteration, Claude just gives up and then comments your test and says return true. And if it doesn't manage to find out why the test is failing, he'll just, fake it. So then we have a platform feature implementation. That's kind of interesting also. This is for rapid prototyping. So when you first develop a function, you would have to put a lot of effort to do the rapid prototyping. So in the EcoThermostat, in the water heating stuff, I have a calcification detection, which is able to detect the amount of calcification which is in the water heater, right? And the idea, I wanted to improve this calcification process. Instead of saying, okay, your water heater is calcified, like 100% of the water heaters are, I'm asking Claude, okay, we are going to modify the calcification detection in the EcoThermostat. Instead of just being an alert, it would be a sensor value. So instead of being just 0 and 1, we would have a float saying 0 not calcified and 1 being very calcified. So I started the project in the root. So it means it has the access to both the firmware and the front-end application in Dart Flutter. Created the to-dos, okay, locate the calcification code in the firmware, modify the code to use a float, update UI or processing code that uses calcification, and test the changes. Okay, why not? Here also I sped up the test by I sped up the implementation by about 250% or 300%. So it would take a little bit more time, but I guess that's fine. So we found the code for the firmware. He found the code for the interface, which are in different subdirectories. And now he starts to write code inside the different H files, okay, global variable for storing calcification. That might be not super great, but it's how he chose to implement it. Note that I didn't give him any information about how to create this calcification calculation, right? I just, say, do whatever you want, and we'll see what happens. This is generally not a good practice, but since I wanted to do a presentation really, really fast, that's where I went. So let's see. So he wrote an algorithm to be able to calculate the calcification based on exponential smoothing. So I had a binary value before saying calcified or not calcified, and afterwards I have a mean average, which is improved over time to be able to have a calcification level more and more precise. And okay, let's say for this presentation, this is good enough. I wouldn't have done it like this, but for this presentation, I won't use this code in real life, but let's say it's okay. once he has this calcification level written, he has to set it as a sensor. So I think next step is to send it to the application using set sensor. He created a new virtual sensor calcification level. And then the last part would be to update the UI. So changing completely the project, going from firmware to the application itself, update the UI. Now I'm going to start to show you the interface that I currently have for the EcoThermostat. Sorry, it's in French. And he will decide by itself, okay, where does calcification make sense? Is it a very, very vital information or not? And he chose himself, okay, let's put it in this location. So he wrote some code in the interface. Remember, it's a huge, huge project. And so this is my Android in theory. He did something, just have to restart the application. And let's wait 1 second. So I didn't know exactly where we implemented it, but if I would have put it, I would have put it here at the end and exactly where it did put it, also with a nice icon and stuff like that. So it's more or less what I would have done, but it took me maybe 2 minutes. So initial prototyping cross-platform features, implemented in a few minutes instead of days. So that's quite interesting also. And that's the last one. It's also interesting. In the last one, I'm talking about bug detection. So I have some code where I will implement a bug. So for example, we have my firmware code sends back some information regarding sensors. And here, instead of sending air quality, I'm sending humidity. And instead of looking for a location where to put a second bug in my code, and instead of, sorry. So instead of writing I'll try to write to an uninitialized PWM port. So instead of writing to outside fan, I'm writing to the inside fan or the opposite. And then using the directory of the complete ESP32 project, I'm just going to ask him, please find some bugs. And we'll see what happens. Here again, I use this think hard, which allocates more thinking process. And then it creates this to-do, checks the to-do, examine the maison qui respire. See, there are also, he also examines the test ventilation that he just wrote before. And he will identify, looking for dependencies, and let's see if it identifies. So what's in dark gray is the internal thinking of the AI. So you don't really need to look at that. So he found 2 bugs. Critical bug line 223, where I put humidity instead of outside air quality. And he found a second bug when setting up the PWM, because I'm writing to the fan outside before initializing it, asking it to fix it. And he's fixing the bug I implemented. And this again took a few minutes. And this would have been actually really hard to find out in the field, because maybe my humidity would have been wrong, but I wouldn't have understood exactly why is the humidity showing wrong in my device. And instead, he would have shown or if I'm showing it, maybe it's easy, but if I'm using it to do some calculations and my air system is not flowing correctly because the humidity isn't correctly computed, then it would have been a nightmare to find out this kind of problems. So that's why I think it's at least one of the huge use cases of AI is to verify code. A code review might have catched that, but it's really helpful to be able to do code reviews yourself without having to rely on some other people's time, and at least I think. So outcomes in embedded development. So that's not real numbers, that's my felt numbers. So in dark gray, integrating external code, there is the productivity without AI, and with AI, I think you can integrate twice faster external code inside your code. Creating test code is 2 times faster, in my opinion. Why just 2 times? Because we just saw we wrote 23 test cases in a minute. I still have to fix that, right? So it's not finished, but it's still really, really helpful for lots of use cases that you wouldn't write otherwise. Creating tools is wonderful. I created lots of different tools for this project that I would never create if I didn't had AI. For example, the tool which is checking both sides, or I have other tools which create automatic debugging, which launch debuggers based on CoreDerms, which are uploaded to an FTP on remote devices. I have lots of different tools which handle automatic translation across firmware and the app. So lots of different, very, very interesting tools. So give it a try, at least for writing toolings. And plus, it's not production code, so that's not as critical as production code if some problems happen or if you don't have the full knowledge of what's inside. Bug diagnosis, okay, faster. You still have to find out the hard ones, but Claude, for example, is still able to start a GDB. If you tell him, okay, I have a crash there, he's able to remotely connect a GDB to your target and set breakpoints and step on the program and find out by himself why something is crashing. Writing initial test code way faster, you saw that. I didn't finish the function for calcification, but almost, so 5 times faster. And the documentation, I think, is the biggest advantage. It's the documentation you wouldn't write, he's writing it 10 times faster, maybe 100 times faster. Overall productivity, I think I'm able to code about 3 times more than before without using AI, so I would suggest giving it a try. Of course, not giving all you can't write everything with AI because he will lie to you, he will write bullshit sometimes, he will try to imagine things which aren't necessary. But if you use it well and just use it for the right components, might make sense. Okay, so AI tools are transforming embedded system development. Okay, greatest impact, enabling critical work that would otherwise be delayed or omitted. And I think that's really, really the plus point of this. Testing, tooling, and documentation. Not everybody loves that, so I don't love that, but I'm still doing it now. Engineers focus on hardware design, architecture, and critical algorithms. Sure. Okay, in my case, it's definitely 100% an advantage. And you saw it, AI loves emoticons, puts them everywhere, so I have tons of emoticons in my presentation. So finally, we can use emoticons. What's the latest information I want to give? We have very, very tight resource constraints in the company I'm creating. We don't have a lot of money, we don't have a lot of time, but we are still able to create big projects and interesting projects. So I think it makes sense in the open source world to use that and in general. I think I finished. So yeah, I'm ready for questions, and I wrote that very small, but please don't shoot the messenger. I didn't wrote AI. Thank you.
Hey, real simple. What's the license of the auto-generated code going to be, and who owns the copyright?
Simple question. Thank you very much. I would say it depends. I'm using, you have lots of different LLMs, right? Some LLMs you pay, some LLMs you don't pay. When you work with LLMs you pay, generally there is a really, really clear licensing question and licensing FAQ. So I can answer that with Claude, all the code I'm writing with Claude belongs to me. So the license I'm giving it has a license, the code I'm generating with Claude has the license I'm giving it to. For other LLMs, it might be a vague question, and I cannot reply that, of course, because in some cases the LLM writes the code and the code doesn't belong to you. Plus, it can reuse the code that you just wrote for other projects. In my case, in this case, the code we're writing isn't reused for training. So yeah, I think it's a case-by-case question. You can't generally reply that. I generally like to think as AI as a contractor. The contractor you're paying for writing code doesn't have to choose the license. You're choosing the license for the contractor. And, but that's only true for contractors that you pay.
Just a small comment. Thank you for using the AI for righteous purposes and saving the planet. And this compensates a little bit for people who generate starter packs and really stupid stuff on the internet with AI.
Sure, thank you.
So it all looked pretty easy, but I think you're quite experienced with Claude or AI in general.
Yes.
What would you think if somebody would start from zero to get to that point where you can formulate the questions to get meaningful results?
I mean, it takes time. It takes time because it's fairly easy to ask the wrong questions or to think that AI, you have to think as AI as an experienced engineer, sure, but without internet access, and he can't read your mind. So if you want to start using it, you just have to keep those two information in mind. Yeah, he's an experienced engineer, he can understand code, but he can't read your mind. He doesn't have access to APIs, which are freely available on the internet. So, but if you give him the right information, you'll be able to create some meaningful code really, really fast, in my opinion. You have to think also, yeah, I'm using Claude, I like Claude, I'm using Claude a lot. I'm not bound to it, so I change, as soon as there are some new LLMs available, which might be better, I generally try them out. But it's also a coding style. I know some people prefer OpenAI, I don't. But yeah, it's coding style stuff. I don't know.
But just give me an idea. Are we talking days and weeks, months here until
you'll get, I think, days. Yeah.
Okay. I thought about using some development cycles acceleration with local LLMs. Do you have any experience with such processes by using local LLMs through Llama CPP or something like this?
Yeah.
And is this also with this good output?
No, the problem is LLMs are like different engineers. So right now, maybe there are 2, maybe there are 3 LLMs that can write code that you can, more or less trust. You wouldn't trust having 10 bad engineers writing your code. You prefer to have just one which is good, right? And that's exactly the same with LLMs. So there are no local llamas right now which can be trusted for writing code as good as that, at least in my experience.
Yes, that's my experience too.
Yeah. And the problem is that that's really something that I hear a lot because, I tried AI and it sucks. Yeah, of course. If you're as saying, I'm writing code with a bad engineer.
You've used the wrong models.
Yeah, exactly, wrong models.
Yeah, so I think the previous question probably answered, but just to be clear, so this is not running locally on your machine. This is like something that's running on some remote server and you're sending like all your files over to it?
No. You're not sending all your files over to it. Basically, you have a multi-level tool. So you have when using Claude Code, you have 2 LLMs. You have Claude Haiku, which is a very, very lightweight LLM, which is on the cloud, and you have Claude Sonnet, right? So when you ask him a question, Claude Haiku will first list the different files in your project, see if there are some files which sound interesting from the file name, right? And then access to these files and read the content of the file. And then the content of the file which might be relevant for your project are indeed sent, or parts of the code are indeed sent to be able to build on top of that, yes.
So so the answer is more yes than no. Then.
Sorry?
The answer is more yes than no.
Yeah, the code is, when you have
it's not all your files, but it's like most of the files that might be relevant for what you're asking.
Here, for example, you saw, as I told you, I have like 50,000 files inside this, and in each and every case, you saw which file he reads, right? You saw that he reads this file, and this file, and this file, and this file. All those files were more or less relevant to the question I asked. So instead of sending 50,000 files, he sent 4. But yeah, sure, this is an LLM which is running in the cloud. So yeah, the files are sent, and yeah.
So like if you rename all your files like through the MD5 sum name, for example, it wouldn't find anything? Or?
No.
Okay.
Yeah, he would do a grep. And based on your request, let's say I want to update the CRC of the image. He will do grep CRC image, and he will get crazy, and it will take you much more money because he will try to find this code, and he won't. So, yeah.
Thanks.
Have you evaluated the environmental impact of such an heavy usage of AI, which I think is something relevant for a project called Save My Planet?
Thank you very much for this question. Okay, let's go. So LLMs, I think, are good for the environment. Okay. Obviously, not for generating stupid images of Ghibli or whatever. But here, for each and every request I'm sending, of course, it uses power, but it generates value, right? So instead of me taking 2 days to be able to generate this amount of value, and I'm using energy as well, right? You creating output and creating value using LLMs is actually, surprisingly, I would say, good for the environment because it accelerates progress and it accelerates the creation of value. Of course, if you just want to generate videos which are stupid, then it generates no value or a low amount of value. But in our case, it's different.
I appreciate your personal assessment, but are there data about how much energy consumption is required for doing something?
Yes. It's actually not, surprisingly, it's not very much. I can, yeah, if you're interested in that, I can send you links. But the amount of energy used for LLMs or used for writing code is actually not a lot. I mean, you can't compare, last time somebody compared it to creating cryptocurrency and stuff like that. So creating money but not creating value. In this case, it's completely different because you're making mankind progress or you're making your code progress using way lower energy than way less energy than a human. So it's actually optimizing energy for creation of code.
Just a side note to the previous question, I've heard that one LLM prompt costs about 11 times more energy than a Google search, so it's around that ballpark. And the question, I have encountered some issues when dealing with LLMs during the development that, for example, when I tried to fix a bug, it fixed it but introduced another bug.
Okay.
Yeah, or when I'm trying to introduce a small feature in some plotting scripts or whatnot, it introduces this feature but completely changes the layout of the plot, for example. And then I'm iterating between few suboptimal versions while the prompt that I'm using is barely different, right? Mm-hmm. So have you encountered this in your work, and what are the solutions that you tried to fix it?
So generally iterating is bad. When you start iterating, it almost already means that you were wrong, that you were going in the wrong direction at the beginning. So generally, when I start iterating more than 3 times with AI, I'm just closing the session, reopening a new one, and restarting. Because the mind of the AI gets messed up, and he's trying to understand something and going in the wrong direction, tries to please you, and at the same time wants to do something by itself. So generally, when you start iterating too much, just close everything, reset your current commit, and that's it. And restart fresh. I never really encountered of creating new bugs when fixing bugs. That's something I didn't have. But when you prompt LLM, just try to be specific about the task you want. Here you see I was pretty open, so that's not necessarily good examples. And plus one thing, generally when you don't want him to fix small things, right? You don't want him to fix a line of code. It's way better to do it by yourself, because fixing this line of code, he might think, oh, maybe it's more complex than what he just asked me. And ask him complicated things, and simple things, do it by yourself. If you know exactly what you want, just do it by yourself. If it involves a few lines of code, 100% it will fail at doing it, or doing it wrong. So I would recommend give him the complicated stuff and keep the easy stuff for you.
So single step only, no iterations?
Yes.
Right.
And clear objectives from the start.
So I tried a bit with neural networks, and what I didn't manage to do is something, or never saw it, something that is aware of Git and commits.
Yep.
Do you have any information on that one? Is any LLM able to produce commits or even rewrite a history?
Yeah, Claude. Claude is able to do that, yes. Claude Code is able to do that. Yeah. Yeah, I can ask him right now, right? Sure. Just checking.
The keyword is model context protocol.
Yeah, MCPs, yes. But right now, if I just... can you please commit? So right now what he's going to do is going to look at the uncommitted work. Do we have internet? Yes, maybe. He will look at the uncommitted work, do a git status, do some git logs, and based on the see git status, git diff, git log, he's looking at my latest comments to be able to adapt the styling of the wording to my commits and the format to my commits. So that's really bad. So he's doing the git add. I'll revert that, don't worry. Doing the git add and see, so he's doing the add calcification, level detection and tracking in firmware, display calcification, update boost function, text, enhance ventilation system tests, and he also put himself as a co-author. So it's possible.
how do you think the cloud will work for something similar to what Marek presented before? Because it's something like relatively new. Because in this case, there's not exactly the code that you are doing, but there's example on the internet for things that you want to do.
Sorry, can you get closer?
Sorry.
Yeah.
I'm thinking, how will cloud work for the presentation that Marek did before, for that kind of work?
I think it's possible. I think it would take, it won't be able to do everything. Definitely not. It won't be able to do everything, but it might be able to do 70% of the work. I mean, you still have the human knowledge, and your human knowledge is 100% necessary. If you rely on AI by itself, it will be good at some point, but at some point it will be just bad or misunderstand you, or try to think on something new and hallucinate some new functions. And so you definitely need an experienced software engineer in the back to be able to create good code. But I think it's, from my experience, even complex code, and I think I know a few people which also tried it out on kernel development, and sometimes it can work. Yes, I know. Look at his face.
Have you tried it for reverse engineering? So you have some. Have somebody tried it for decompiling? Provided a blob in assembly, and you get some C code or Rust code, or.
Yes, sure. I mean, you can. He's generally really good at using common knowledge. So you can use it for decompiling and understanding code which is written in assembler. I mean, it's not perfect. Like a human could make mistake, it will make mistake. But if you take the right approach, it might be really, really helpful to tackle a lot of the first issues that you would have. For example, I received a 300 pages request for quotation a few days ago, 300 pages. And I gave it to the AI and asked him to sum up this in 10 pages, and it did a good job. And so it might not solve everything, but yeah.
How did you know it did a good job if you didn't read it?
Because then, based on the sum up, you're able to find, okay, does this make sense? Okay, and then you're looking inside the full documentation. Or does this make sense? Yes, no. I mean, it wasn't perfect, but it took me like a bare 5 minutes instead of 10 days to just read this stuff. I won't do it, by the way.
That's a shorter question. Nowadays, the code or all the other LLMs have been trained on code written by humans, so we can assume it has some level of quality. What if in the future all the developers start relying more heavily on that, so that I have a project, I integrate something, I don't know the details, it basically works, just go with that. So you have more and more code developed by LLMs, which is perhaps not optimized, or you have some problems, and new LLMs are trained on that.
Yes.
Do you think there might be some sort of biasing toward some unoptimized or problematic behavior?
Yes and no. So first, indeed, LLMs are trained on code written by human. But there's also some kind, I don't know exactly, and there's some kind of intelligence behind that. So it's not only about writing code which is written by human. I mean, if you give him the right specification, an AI can write code based on a programming language that doesn't even exist. So using language that never existed, or with semantics that never existed and that it never read. So there is some kind of intelligence in the background. I don't know, there might be bias. I mean, it's putting smileys, it's putting emoticons even in Git commits, so I don't know. But yeah, I don't know if it replied.
So personally, I'm into IT, programming, and computers because I think it's fun. So my question is, why is the fun?
Oh, I mean, it's still fun. I mean, coding with AI is not easy. It's complicated. because instead of, definitely, because instead of just coding once, you're coding 3 to 4 times faster, right? So you have to embrace so much code and understand so much code and write so much code. It can sound easy if you're staying at your previous productivity, but I mean, if you like coding, you won't stay at your previous productivity. You will just produce 3 times more, and then you have to understand 3 times more code, right?
Well, what I don't understand is you didn't write a single line. You're just like you're reviewing something that the AI did. So like you're not writing code. That's the fun part, I think.
Here, I mean, I just have 30, 40 minutes, right? But in real life, I will definitely, I mean, when he writes 500 lines of code, of course I have to read that and I have to understand that. I need to fix that, what he did wrong, and he will do things wrong. Otherwise, that would be just vibe coding 100%, and you will have a shitty product in the end. That's 100%. So yeah, you still, instead of writing all the code, you're debugging more, understanding more. It's like managing a team of 5 where you're the lead software engineer, and you have to review the code written by a full team. So I love code. I mean.
Okay, 100%. So you're passionate about code review. Okay, maybe more than I am. Yeah.
Let's do 1 or 2 more, and then we'll continue the conversation at the bar at the restaurant.
I need a beer.
This is another carbon footprint question. Can you go back to your first slide with your products, please?
To the first slide?
Yeah, the one with your 3 products, just to make sure.
Yes, sure. I can try. So this presentation was written with Claude. It's full HTML. And as soon as I wanted to update something, I'm saying, hey, please add that, or please modify that, or yeah. This one?
Perfect. Yes, this one, perfect. As Jacopo said, you're using energy basically to run AI for your project, but you're also manufacturing PCBs for that themselves run on energy. Have you tried measuring the carbon footprint of your devices, both manufacturing, delivery, power consumption, versus the gain of your full solution? And basically, I'm interested in how much time it takes to break even.
Sure. So it completely depends on the project. So the first project is the less efficient because we will cut a lot of metal to be able to create it. So this is not the most environmentally friendly, but it will still be erased within 3 years. The second project would be erased within a few months. So in terms of energy gain and energy creation for creating the project. And the last one is the fastest. It would just be a few days because if you're managing to, I mean, a water heater has a staggering amount of energy consumption for nothing. Really, it's amazing. And just replacing one card without replacing your water heater, that's a huge amount of gain in energy consumption. So yeah, we are taking this in account, definitely. And for example, for the first project, we are thinking about solutions to be able to improve this.
Thank you.
You're welcome.
Do you run into token limits when you analyze your big repository, or?
No.
Okay, and you don't have a limit of maximum number of queries, for example? Or
yes, the problem is the more queries you ask, the more context, the bigger the context you will get, right? So each and every time you will ask a new question, he will have the context of all your old questions plus the new questions. So the context will grow. All of this is working with API request, and the bigger the context is with an API, the higher the price is per request. So at first, a request may cost a few cents, and after 20 queries, a request could cost €1, $1 USD or something like that. So when I'm working, I'm trying to keep my context low, so asking dedicated stuff, and that's what I was talking just before. I'm not iterating a lot. I'm asking one question where we would find exactly the right pieces of information, and if I have to fix a second bug, I won't ask straight afterwards. I will close the session, reopen a session, and re-ask the same question, because or re-ask the different question, because if I don't do that, he will send back the whole context of the first bug fixing together with the second bug fixing. So first, he will have his mind polluted by the first code, and second, it will cost 3 times more.
Thank you.
Am I sure you are presenting, or is it a cloned version of you?
Who knows?
Thank you.
The presentation would be funnier if it was Claude.
Okay, thanks a lot, Christophe.
You're welcome. So this is the QR code for the venue.
Yeah, so if you need to get to the venue, this QR code will take you right to the Google Maps. Otherwise, walk along the beach until you find a bunch of other geeks and you'll be at the right place. Okay, see you soon.
Pour demain, il y a un truc plus important, tu regarderas dans les mails, parce qu'il y en a eu plein. Il y a la nana de Igalia qui a dit qu'il n'y avait pas eu de post sur Fostodon et tout ça de leur sponsorship.
Moi aussi, mais c'était il y a longtemps. Mais
elle demande si en cas tu peux repousser un truc de thank you sponsor. Non, elle dit pas le sien, elle dit qu'il n'y a pas eu de thank you